Okay, so we had a couple questions off of homework 12, so I'll just kind of give you a little hint video here if you need it. We'll start with number 7. So the first thing that you should be doing is your slope field. Remember, you're just plugging in each point one at a time and then sketching the approximate slope of that value. So for example, let's say that I was plugging in any time that y is 0. That would be that whole row. Well, whatever x is, if I multiply it by 0, it's going to be 0. So these all need to be flat. Okay, then this column here is when x is 0. Okay, now think about if x is 0, then when I multiply that out, it's going to come out to be 0 as well. So automatically, I have every point there already finished. Okay, now let's go through this row here. So this is 1, 1. This is 2, 1, and 3, 1. Okay, let's do 1, 1 first. So if I plug that in here, I'm going to have 1 times 1 divided by 2. Okay, that comes out to be a half. Then I'm going to come over, I'm going to have 1 times 2 divided by 2. That's 1. Okay, then I'm going to have 1 times 3 divided by 2, 1.5. So as you can see, I had a slope of a half, then I had a slope of 1, then I had a slope of 1.5, so I can see that my graphs are getting steeper. Okay, then I'm going to come up a row. This is 1, 2, 2, 2, 3, 2. And then I'm just following this same pattern. So I would say x times y, 1 times 2, divided by 2. That comes out to be 1, which means that these two should both match. Okay, then 2 times 2 divided by 2 gives me 2. So that should be steeper. Then if I do 3 times 2 divided by 2, okay, that's going to be 3. So that should be even steeper. Okay, etc. until you fill out your chart. Okay, down here, this is -1, or wait, sorry, 1, -1, 2, -1, 3, -1. And then I would just plug those into this formula here. So I'd have 1 times -1 is -1 over 2, which means that should be downhill. Then I come over here, 2 times -1 is -2, divided by 2 is -1. So if that's minus a half, -1 should be a little bit steeper. Then I come over here, that'd be -3 over 2, which would be even steeper. And then you can hopefully finish out the other side. Okay, next one. Oh wait, I have to sketch a solution, so we'll finish it. So -1, 1, and -2, 1. Okay, if I multiply -1 times 1, I get -1, divided by 2 is -1/2, exact same as this one. So these should have about the same slope. Then I come over here, -2 times 1 is -2 again, divided by 2 is -1. So these two should be about the same. Okay, then I'll come up here to -2, 2, and -1, 2. Okay, multiply together, -2 times 2 is -4, divided by 2 is -2. -2 times, or -1 times 2 is -2, divided by 2 is -1. So these two should match perfectly. Okay, and then here I have -1, -1, and -2, -1. Okay, so think about multiply -1 and -1, I get 1, cut it in half, that should match this slope of a half here. And then -2, -1, product is 2, divided by 2 is +1. Okay? All right, so part A says, on the axis provided, sketch a slope field for the given points. Done. Sketch the solution through 1, 1. So 1, 1 is about right here. And then I'm just going to follow the shape of the line. So it looks like here it's going up. Then here it looks like it gets flat, and then it goes up over there. Okay? So remember, you're just kind of following the shape of the curve there. Okay? Go down to part B. Says, write an equation for the tangent line. Okay, 2 things I need for the equation of the tangent line. I need a point and a slope. Okay, the point they're giving me right here is 1, 1. The slope I need, so I'm going to find dy dx at that ordered pair. Okay, which I can plug back into here is going to be 1 times 1 divided by 2, which is a half. So it's going to be y minus 1 equals a half x minus 1. Then it says, use your tangent line to estimate f of 1.2, which means I'm going to plug that into my line. So I would have y minus 1 equals 1 half 1.2 minus 1. Well, half is 0.5, 1.2 minus 1 is 0.2, and if I want half of 0.2, that's going to be 0.1, and then I can add that one across, so y equals 1.1. Part C. Use implicit differentiation to find the second derivative in terms of x and y. Okay, dy dx equals, I'm going to rewrite this as 1 half xy. Okay, and the reason why is I don't want this to look like quotient rule. Okay, if that's quotient rule, that's going to take me forever. But if I think about it as a half x multiplied by y, then now it's a product rule. So my u is going to be a half x. My v is going to be y. That means my u prime is just a half, but my v prime is going to be dy dx. So let's write our second derivative. D squared y dx squared equals, okay, let's do this diagonal first, 1 half y plus 1 half x dy dx. Okay, then it says in terms of x and y, means that I can't leave this dy dx chunk in my equation. So all that I have to do is rewrite it with that taken out. So I'm going to put or half y, half x, and then in that spot I'm going to put xy over 2. Okay, and remember that means in terms of x and y. Okay? Then from there it says determine whether your estimate in part B was over or under. Remember that for that we need concavity, which means that I need to check the second derivative at my point. So d squared y dx squared at 1, 1 is going to be a half y. I'm just plugging into this version. You could use that one. It doesn't really matter. Okay, but I'd have a half y plus a half x times dy dx, which remember came out to be a half. And if I have positive stuff plus more positive stuff, we know that's greater than 0. Okay, what does that tell me? That tells me that y is concave up around the point 1, 1. And for a concave up graph, I can see that my tangent line is always going to fall below. So I'll put, so tangent line is below actual value. Okay? All right, last part, part D. Find the particular solution with the initial condition f of 1 is 1. Okay, well remember dy dx is this. So the first thing that I have to do to solve that is to separate. So I like it better like this because I can see that my 1 half x is going to stay, but my y is going to have to move. So I'll have 1 over y dy, 1 half x dx, and then integrate, integrate. Okay, so remember, you're going to separate your differential equation first. That's step 1. So the integral of 1 over y is going to be ln absolute value y. The antiderivative of this, x is going to be squared. But then if I divide a half by another half, okay, that's going to come out to be a 4th x squared plus c. And then over here, if I have an ln of y, I'm going to e both sides. E and ln are going to cross out, as usual. So I have y equals ce to the 4th x squared. Then from there, I'll take my ordered pair here and I'll plug it in. So it says f of 1 is 1. Well, then 1 is the answer when I plug in a 1. So I have 1 equals ce to the 4th. Okay, because remember, 1, if you square it, nobody cares, right? Okay, so then from there, if I want to get c by itself, I'm just going to divide by e to the 4th on both sides. So I have c equals 1 over e to the 4th, Or if you like it better, you could write that as e to the negative fourth. Really doesn't matter, either one will work. So then remember, if that's my plus c, then I just need to change my equation here. So it would be y equals e to the negative a fourth, e to the 1/4 x squared. And that would be your particular solution. Okay, also again, remember, you could rewrite that term like that. It's really up to you if you want to have a fraction or if you want to leave it alone. Okay? All right. Then the last question that I had was for your slope field here. This one has a lot of dots. So if you want to, you can go ahead and use the slope field generator. Remember, you can just Google slope field generator. And the one that we used in class was by Desmos. Okay, on the AP test, they won't give you one this big, but it's good to practice and kind of get the idea. So if I'm doing x over y, this, for example, is 1, 1. Divide 1 by 1, you get 1. Divide 2 by 2, you get 1. Divide 3 by 3, you get 1. Same thing down the other way. Negative 1 divided by negative 1 is positive 1. Negative 2 divided by negative 2, etc. Okay, anytime that x is 0, I'm going to have flat slopes. So these are all going to be flat. But if y is 0, okay, also notice they're telling you it can't be 0. That's because you would get an undefined slope. And remember, you're supposed to leave those blank on the slope field. So that means everything on this axis here should be blank. Okay? Then from there, you'll just plug in the other point. So for example, this is 2, 1. So if I do 2 divided by 1, I get 2. Then if I come out to 3, 3 divided by 1 is 3, so it got steeper. Okay, this point here is 3, 2. So if I do 3 divided by 2, that's going to be positive somewhere between 1 and 2. Okay, you get the idea, you're just doing it. Okay, then it says, sketch the slope field through 0, -1. 0, -1 is here. Okay, but you would have to have the rest of that filled out. Again, use the slope field generator if you don't want to plug it in, but it's good practice. So this is 1, -1. 1 divided by -1 gives me -1. -2 divided by 2, -3 divided by 3. That's 2 divided by -1 is -2. 3 divided by -1 is -3. 3 divided by -2 gets a little bit less steep. 1 divided by -2 is -1/2. 1 divided by -3 gets flatter. 2 divided by -3 is somewhere in the middle. -1 divided by -2 is +2. -1 divided by -3 is, -1 divided by 2 would be -1/2. So that should be a little bit flatter, actually. And then my next one, if I do -1 divided by 3, should go to 1/3. So as I go down, these should be getting a little bit flatter. -2 divided by -3 would be somewhere in the middle. And now that I have that, I can go ahead and sketch my graph. So 0, -1 is here. I'm going to be going towards the asymptote there, and then it looks like I'm coming down this way. So maybe it's like a hyperbola or something like that. Okay, so check, we drew our particular solution that passes through 0, -1. That's this guy right here. Okay, that's your solution going through that point. Part B says use the tangent line. Hopefully you know how to do that given that we just covered it. But you have your point right here. You have to find your slope, which is dy dx at 8, 2. You would plug these in here. So if I do x over y, that'd be 8 divided by 2, which is 4. Then I can write the equation of my tangent line. And then I'll take the decimal they give me, sub that in right there, and then blah, 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 you can do it. Okay, part C, you want the second derivative. Okay, you are going to need to use the quotient rule there. So your high is going to be x, your ho is going to be y. D high, the derivative of x is 1. D ho, the derivative of y is 1 dy dx. So your second derivative, dy dx squared, is going to be ho d high, so 1 times y, minus high d ho, x dy dx, over ho squared, which is y squared. In terms of x and y means I can't leave it like that, so I would write it as y minus x, and then dy dx is x over y squared. Then to determine if your estimation is over or under the actual value, you would have to sub your point in from up here. So d squared y dx squared from part B at the point 8, 2 is going to be my y value 2 minus my x value 8 times my dy dx value, which was 4. And then divide by my y squared, which is 2 squared. Now notice that I don't know exactly what that number is, but I know that if it's 2 minus 32, that's going to come out to be negative. And if that comes out to be negative, then that means that my graph of y is concave down around the point 82, which means that my tangent line is above. It's an overestimate. Okay? Because think about concave down graph, your tangent line is going to be above it. Okay? So hopefully that helps, and if you need more help, come to tutoring. Okay? Have a great day.